In this video, we're going to talk about creating frequency distributions in Excel. And so to do that, we're going to use the frequency function. Let me tell you a little bit about this population. We have 35 subjects in each of 5 groups. We have extreme myopes, we have myopes, emmetropes, hyperopes, and extreme hyperopes. And we have measures of spherical equivalence and measures of relative peripheral refraction. And we want to look at the distributions of all of these different groups of these variables in these different groups. First thing I'd like to do as I'm looking at this is maybe center the numbers. So I'm going to come over here in this corner right above A1. I'm going to click on it, and then I'm going to go to the home screen. I'm going to go find this little icon that says center. And now all the numbers are centered. But I don't really want this column centered. So I'm going to come up home, and I'm going to click on the left adjusted, left aligned. So there we go. Now it looks nice. It doesn't make any difference to our calculations, but it looks nice. Alright, now you will also notice I have done something called freeze panes, and just to remind you what that is, under view we have freeze panes, and if we click in a spot, let's say we're going to click here, we're going to freeze our panes above here, freeze the spreadsheet above here and over here. So view, freeze panes, freeze, and then it put in 2 lines right here. And what that does is it lets us come over here and see the left hand margin is still there, and up here we can scroll down to the bottom but still see our labels. That just makes life a lot simpler. That's view, freeze panes. Very handy little way of entering data. Okay, now I would like to actually have all of these frequency distributions on the same scale. And in order to do a frequency distribution, I need data, the column of information. I'm going to do it for each one of these separately. I need the data, and I need something called bins. Bins are like boxes. So you find a minus 3.92 and you put it in one bin, and minus 3.43, you might keep it in the same bin. Every bin between minus 4 and minus 3 would be in one bin. We don't know what we're going to do because we don't know the range yet. So the first thing we're going to do is we're going to find the range of this entire data set, not just myopes, but everybody. And so we're going to use a function called min, and that's going to be equals min. And then you can see that it's pulled down this function. There's min, min a, min a bunch of things. And when I get to here, I can either hit the left parenthesis or I can hit the tab key. And the tab key capitalizes, though that doesn't really matter. And it tells me, okay, now you need to know the numbers that you want to check out. So I'm going to go up to this first file. When you freeze panes, make sure that you have consecutive numbers here at the freeze point, because it's very easy to go all the way down and then start like at row 19 or something, and you'd be very unhappy. So now I'm going to do control. I'm holding down the control key, shift, and I don't know what all this is in a Mac, but in a PC it's control shift down arrow, and it highlights everything in the column there. And then while I'm still holding on control shift, I'm going to hit the right arrow, so that it goes over to the side. Now you can see that I have marked the entire data space. And so that, and it's from B5 to K39. Now I'm going to close the parenthesis and hit enter. And that's the smallest number in this frame. It's minus 4.11. Now I need max. So I'm going to do the same thing. For all functions, or for all number or anything, except for text, you're going to start with an equal sign. And then we're going to do max. And there we see our max function equals max. And then I can hit a tab, and it capitalizes it, puts in the parenthesis. Come back up here, again checking to make sure I'm at 4 and 5. Click there, go over and down. Just went a different direction that time. Same principle. And then I'm out here in no man's land. I'm going to close my parenthesis. And again, I'm from B5 to K39. Hit enter. This time, it gives me the biggest number, which is 9.25. So somebody's a 9.25 hyperope or something. Alright, so to maintain my range, I need to go between minus 4 and 0.11 and 9.25. So what I'm going to do is minus 4, I'm going to make a column here of my bins. I suppose I could start at minus 4.5. Oops. 0.5. And then, now I could go, I think I'm going to go in half diopter increments. We'll see how that works. So we'll go minus 4. And now I'm kind of lazy, so I'm going to highlight the minus 4.5, and then down in the corner here, see how the cursor changes from that little cross to the thick cross to the little black cross. I want that little black cross. I'm going to drag it down, and as you notice, beside it there's a number, minus 1, minus 0.5, 0, 0.5, and so forth. I'm going to go down all the way to 9.5 and let everything go. And there it filled in my bins from minus 4.5, so from the minimum value to the max. Alright, now what I want to do is I want a frequency of extreme myopes for their spherical equivalents. And so I'm going to go equals frequency, there's the function, tab. Now it says, okay, I want a data array and I want a bins array. And the data array this time is not that whole thing, just this piece. And then now I've done the data array, I want to add the bins, so I put in a comma. And now it's ready to take the bins. And I have to scroll back up to get to that first part. Oh, and look at that, it covered it. Isn't that nice? I'm going to start at the bottom. And I'm going to hold down the shift key. And I'm going to go up to just below bins. And I'm going to close my parenthesis because it just asks for two things, a data array and a bins array. And now I have two ranges in there. Close my comma and hit enter. Now, what that says is there are no observations between -4 and 4.5, -5 and 4.5. There's 1 at -4. Let's see if we can find that. I'm going to sort this row. Data sort. See how I have one value that's -4.11? So between -4.5 and -4, I have one value that's 4.11. And then between -4 and -3.5, 4.01 or something, and 3.5, I have 6 values. So we have 1, 2, 3, 4, 5, 6. And then the next one's 3.45. That's going to be up 1. That's 4 of those, and 11, and 5, and so forth. And then we had all of these values here that we didn't use, but that's okay because we'll probably need them for the others. But here's that function is up here, and it went down and just gathered things from over here into these bins. So let's just go ahead and call this extreme myope spherical equivalence. Okay. Now let's look at myope. Spherical equivalence. Alright, so let's do this one. It's the same thing. We just go equals frequency tab. Come here, make sure I'm at 4 and 5. 5. Control Shift down arrow, comma, and then our bins. We'll start down here. And close the parenthesis and hit enter. Now see how the distribution has shifted a little bit? It was here, and now it's down to here a little bit. And you can do this for each one. All right. Now this could take a little bit of time, and if we wanted to take a little shortcut, what we could do is come over here and we would copy this one, copy, Control C, copy, and then paste. Now that looks kind of a weird thing. Let's see what that was. Notice that rather than bins marked, it's EM spherical. But it did move over to emmetropes, so that's a good thing. But we have this relative change that everything, since I copied from here to here, it moved everything, the data bins, or the data and the bins, over one. And that was correct for the emmetropes, but it wasn't correct for the bins. So we can just move this guy back. And now we have the distribution for the emmetropes. Again, they're shifting down, going down this line here. Very handy. Okay, let's do this again, but we don't want to have to move it every time. So let's come up here, and we want, so we have the data and we have the bins. The data seems to be happy to move from one to the next, but the bins are being wiggly, and we don't really like that. So it's moving over, and we don't really want it to do that. So there is, if we click right there on the O5 or whatever that number is, then we can hit a function key, F4, and what that's going to do is it's going to give us some dollar signs there. And so that says fix this point. So we want to fix the 4.5. And then over here, we're going to click there, and we're going to say fix that. And so it's a $O, which says freeze on the 0, or on the O, and a $33, which is free at the bottom here on row 33. And we're going to hit enter. And then we're going to copy that. We're going to put it over here. Now, notice, it copied the O5 and the O3, but it went to the next column on this side. So let's look and see what that is. See, now we're correctly highlighting bins, and we have hyperope. Let's just copy these guys, even though I didn't really name them quite like that. Change my naming convention a little bit. And this is going to be spherical equivalence, and right here we're going to start relative refraction. And let's copy from here. Again, notice down here it doesn't have the main frequencies. It's taken it from above, but we come up to here, we have the frequencies that we're interested in. So we're going to copy, Control-C, copy, and we're just going to move, we're going to do our little cross. Actually, I did Control-C, but okay, I'll just do Control-V. Oops, I just did it in the same place. Control-V. Okay, there we go for the next one. Now, this time, let's do our little cross. Let's come all the way over to here. And now we have our distribution for everything. We have our spherical equivalence, which you can kind of tell is shifting downhill, down to hyperope. And then our relative refraction. And honestly, we could have done these as set up two separate bins. Might have been a better idea. But anyway, we'll just see where this gets us. Now, let's look at a graphical illustration of this. So let's go to bins, and let's Control-Shift down, and let's move over, so I'm holding Shift key and right arrow, so that I have covered both the bins and the EM sphere. And I can now insert a chart, and I'm going to want one with lines on it. I might even, I'm going to make them a little smooth on the edges. And so there we go. We get EM sphere, and we get that. Now what would be nice, now we can add the next one. We can come in here and select data. I right-clicked on the figure, select data, And then we can add median spherical equivalence. We can give it the same bins. Notice here it's remembering, oh, maybe not. Well, it's 13, it's not a 5. So we need to go up here, get to our 5, and then Control Shift down arrow to mark that. That is our x-axis. And then down here, we want our data, which is, again, it has shifted down, so we gotta be careful about that. Control Shift down arrow. And okay. 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 Now, it looks like our graph is cut off, but that's because it's above the fold. So we're going to bring that down below view panes, and we can see we have the extreme and the myopic. Here's 0. Let's do this again. I'm going to get rid of this graph because I like it, but I am, as I said, kind of a lazy guy, and I want to do it quicker. So I am going to highlight bins all the way over to the extreme hyperopes and down arrow. I'm going to come back up here. Now I'm going to insert again a chart. Last time I added the little dots. I don't really want to do that. I want to do it without dots. I'm going to hit that. And here is our chart. Let's take a second and look at that. And what we have is EM, extreme myope spherical equivalent, myopic spherical equivalent, and one thing I didn't mention, these are 35 children who are 10 years old, and their classification is what they were at the end of this longitudinal study. And so the emmetropes are at 1. They probably are going to shift a little bit more as they get a little bit older. But right now they're at 1. They're going to be future emmetropes. And then the yellow is the hyperopes, and the blue is extreme hyperopes. Notice they're really out here. They're kind of out of they're just out of it. So there you go. So we have used the frequency. We've used the frequency function to calculate our numbers at each of these bins, and then we've done a graph to plot it out. Pretty fun, huh? For spherical equivalence, anyway. That's it.